Okay, so we've talked about a few things so far. We've talked about right triangle trigonometry. We've talked about law sines, law cosines when we don't have right angles. Today I want to do a couple of examples to kind of wrap it up where we are, what we need to use isn't necessarily quite so obvious. So we may have to do some things to adjust. For example, look at a shape like this. This is 96 degrees, 18 feet. $26 feet. And 15 feet. We're going to assume I'm going to give you that these two sides are parallel. I want to find the area of this. How can we use trig to do this? Well, we need to know some lengths, don't we? Or we need to have some triangles, first of all. One thing we always try to do is make right triangles. We can maybe draw a cross here and make a right triangle there. Problem is if we do that, we don't know any of the lengths or any of these angles here or here, do we? So making a right triangle there won't work. But in the last few days, we've learned we don't have to have right triangles. If I cut this across here like this, so that this is a 96-degree angle, that makes this line parallel with this line. How does that help us? Well, this is a parallelogram down here in the yellow now, which means this side here has to be the same as this one down here. So this is 15. This over here is, well, yeah, this was 18. So 26 minus 18 makes that 8. So now we have a triangle there where we have two sides and the angle in between them. Can I find the other sides? Mainly the only side I really need is this one, right? What am I going to do? So we go 8 squared plus 15 squared minus 2 times 8 times 15 times the cosine of 96 degrees. We'll do the square root of that, right? So this will be c squared, so I'm just going to square root of that. So I'm going to punch that all in. Second, square root. 8 squared plus 15 squared minus 2 times 8 times 15 times the cosine of 96. 17.2 or 17.72, I should say. Feet should be in. So now finding the perimeter of this, I have 18 here, 15 here, 26, and 17.72. So add that up and I have my perimeter of what? .72 feet is my perimeter. Area. What if I wanted to find area? Area is actually way easier even. Because I gave you because we know this side and this side are parallel, this is a trapezoid with bases of 18 and 26. All I need to know is a height. Can I find a height? Not 15, no, because the height has to be perpendicular, and that's not. I cut it across here, though, at a perpendicular. What's this angle here going to be? 6 degrees. Right. This will be 90 here, and if this was 96, you subtract, you got 6 degrees there. So my height, here's my right angle, here's 6 degrees. Oops. This is 15 feet. I'm looking for this side here. I'll call that X for now. This is the adjacent and the hypotenuse. So I'm going to use what trig function? Cosine of an angle is adjacent over hypotenuse. I have the angle, which is the 6 degrees. The adjacent side is what I'm looking for. My hypotenuse is 15. Put this over 1. It's the cosine of 6 degrees times 15 divided by 1. 14.92. So that's 14.92 feet. So now I can use that with my trapezoid formula to find an area. That area is going to be the average of the bases, 18 plus 26 over 2 is the average of the bases, times the height of 14.92. So 18 plus 26. Make sure you always hit equals before you divide by 2 there, just so it works out right. Gives us 22 is the average of our bases, times 14.92. 328.24. That's square feet. That is the area. That's the average of the bases, 18 plus 26 over 2. Averaging this base and this base. They'll give you the equivalent size of the equivalent rectangle, right? What do you guys think? 18 plus 26 and then divide it by 2 because that gives me my 22 is the average of the bases then. That's halfway between 18. What's that? Yeah, 18 plus 26 divided by 2 gives me 22, and then I multiplied that by the 14.92. Well, let's say that the radius of this circle is 30 feet. And let's say that from here to here is 40 feet. I want to find the area of this whole thing. How am I going to do that? Well, first thing I know that if I draw a radius on that circle with a point of tangency, that forms a right angle. So I know that's a right angle. This is 30 feet. I also know that this down here is also 40 feet. Because if there's two tangents that intersect, they make the same length. I draw that in at a right angle. That's also 30 feet, of course. And I know that if I cut this across here, it cuts this angle in half. Maybe I'll draw that a little better. Like that. That's a little better. So what I am dealing with right now, I can actually find the area of this triangle already. It's just 30 times 40 divided by 2, which makes it 600 square feet. So this one over here is also 600 square feet because they're identical. So I just have to worry about the rest of this circle, the sector of the circle over here. And to do that, I need to know this angle. So to know that angle, I need to know this angle right here. So if I can find this angle right there, I can do it. So what I have, if I redraw this, this is 40 feet, this is 30 feet. This is the angle I'm looking for. What two sides do I have? Adjacent and opposite, which means I'm dealing with the tangent. Tangent is opposite over adjacent. I don't know the angle. That's what I'm looking for. Opposite side is 40, adjacent side is 30. So my angle is the inverse tangent of 40 divided by 30. Second tangent, 40 divided by 30. 53.13 degrees. So 53.13 degrees here, 53.13 degrees here, which makes this angle out here 253.74 degrees. Does that look right? Yep. Well, now that I have that, finding this area should be pretty simple, right? It's the area of the whole circle. So pi, 3.14, times the radius of 30 squared. And then times the 253.74 over 360. Look familiar? So 3.14 times 30 squared times 253.74 divided by 360. 1991.86. We add that all up, we get 3,191.86 square feet. What you thinking? Don't care anymore?
Can you go down a little bit?
The 1991.86 was the area of this piece here. Then I had the two 600 square foot triangles. Okay, I want you guys to work on these for a bit. Make sure you got them down. In your book, page 797, it is exercise 36-14. Problems 1 through 24. You can start by doing just the odds. If you got them, that should be good. There is a test tomorrow.